So this is our COP3530 Project 2 submission. We are Team Stay Dry, and what we're submitting here is a web application that aims to find the ideal travel locations out of the entire continental United States. So we compiled everything, all of the code, into one command that you can just start. It reads um, tons of CSVs, multiple hundreds of thousands of lines out of two different data sets. This is an example of one here. This is the NOAA data set of extreme weather. And we compare that to a normalized US cities database that contains all of the cities in the United States. And that's how we make the comparisons here. As you can see, we read all of the files in this data folder here. And then we went ahead and we started a locally hosted server. So if we go to this link right here, it should just load right in to our web application. There's a couple of different features here. Number one, obviously the most straightforward is just an autocomplete. So I want to go to Gainesville, Florida, for example. You just type in Gainesville, and then, it did autocomplete to Gainesville, Alabama. If we click on this, you can see Gainesville, Alabama does have less storm events overall, meaning that it is, according to our data set here, within the last 25 years, it has had better weather than Gainesville, Florida. And as you can see, just by going through, we can see that that's true. As you can see, Gainesville has a lot more storm events. And then, we also have some other things in here. We have a 7-day average, last 7 days. This is current up to time. So like as of November 8th, 8:38 p.m., it is 83.5 degrees Fahrenheit in Gainesville, Florida. The 7-day average of the highs was 78.46. That means that we're currently 5 degrees higher than average. You can see that we have a chart down here. This is a historical chart of the last 7 days. As you can see, we've been having a steady increase in weather recently. It's just been getting a little bit hotter, even as we go into the winter months. And then we have a ranked list here. This is constant no matter what we type in here. So we go to Millersburg. This is going to stay constant. This is a min heap implementation of throughout the data set. Throughout all 25 years, the cities that appeared the lowest. We did have to cut out some cities because there was a lot of zeros. Didn't want to fill it with just zeros because a zero usually means that we missed the city in the NOAA database or something. So we filled it with only non-zero, cities in the data set just to get an actual sort of gauge of what's going on over there. Other than that, you can go through each month. These three are constant because they're current weather. This storm events in the month is going to change because the NOAA database is per month. Other than that, we have obviously the autocomplete here. This is weighted going towards the city. So if I type in the SOUL, as you can see, Soulsbyville, California is like the lowest in the data set. And as you can see, the autocomplete straight away figures out that we're trying to go there because it has very few storm events in the entire data set. Other than that, that's kind of our project. That's pretty much everything that we have. And then, we packaged it all really neatly and nicely into this website where you can sort of see everything come together in one nice user interface.